Remember
Bill,
this?
the cosmic ray. Okay.
Okay.
Guys, this is being recorded as well, just in case. Just keep your
Yeah.
cameras and your voices off.
Yeah. Build a cosmic ray detector to see tracks left by particles from space. A few years ago, I came across this on the interweb, and I was gobsmacked to see how easy it was to do, because we all have this idea of the detecting particles, fundamental particles or cosmic rays, and that you needed to go to CERN or one of these places. But for the larger particles, it's as easy as falling off a chair. I couldn't believe it. So there's, if you Google or go to YouTube for build your own cloud chamber, you'll get all the information. So I just basically took one of the threads and I went with it, and I said, okay, we'll give this a try. And I literally did it on the kitchen table, and I subsequently gave a talk to Mac there about 2 years ago. And now, unfortunately, given the talk this way, it's not, you don't get the full whack of actually being there, because some people have said to me it's quite spooky, but to me, I think I get it has the wow factor. But a lot of people are kind of, it's like having a seance or something, but you'll see what I mean as it goes on. Just a little bit of background. Cosmic rays are high energy subatomic particles that constantly bombard the Earth from outer space. Thousands of these particles pass through our planet and through us every second. This natural radiation is harmless and invisible, but the tracks that the particles leave behind can be seen using a cloud chamber. Building a cloud chamber is easy and requires only a few simple materials and steps. Materials: clear plastic or glass tube. Give an example: a fish tank with a solid lid. Now, solid lid, I didn't go with. I'll explain that. Some felt, isopropyl alcohol, or rubbing alcohol as it's called. Any chemist will get this in any chemist. Don't drink it, by the way, or don't add it to any drinks. And dry ice. I actually thought that the dry ice would be my biggest problem, but it turns out that there's a company in Port Ireland that makes it, Polar Ice, and it turned out even more fortunate for me at the time. One of the directors is a next door neighbor of mine, which I didn't know until I was just chatting to him one day, and he actually supplied me free gratis with the dry ice for my experiment and for the talk. Right, how you do it: cut the felt so that is the size of the bottom of the fish tank, and glue it down in the tank. Once the felt is secured, soak it in the alcohol until it is saturated. An important bit is drain off any excess alcohol. Place the lid on top of the dry ice so that it lies flat. You want to have the dry ice in a container or box, so that goes without saying. Flip it upside down so that the felt covered bottom of the tank is on top, and place the mouth of the tank on top of the lid. Wait for 10 minutes. Now, that's the important bit. You have to wait 10-15 minutes, then turn off a light and let the action begin. Now, there's my kit. Polar Ice is the company that makes it. You'll see my fish tank. I didn't use a lid. I just used baking tray, basically, which fitted the lid perfectly, and the dry ice, the alcohol here, there, and you'll see that on the top of the dome of the fish tank, you'll see the felt, and that is the kitchen table. Now, just go through the making of it. on the web, of course, you come across the diagrams. The ideal fish tank would be the square one, but I went with what was handy for me to get. I picked up that round fish tank in one of the pound shops for 15 euros or something like that. You know, did the job. And you can see there where I put the felt on the bottom of it there. Next, add the alcohol. There she is. And allow it to soak in and make sure that the felt is pretty sodden with the alcohol. Then you get your dry ice, and there she is on the right hand side, sitting on the dry ice. Then turn your tank upside down and place it on the dry ice. So that was me following the various steps. And then after 10-15 minutes, lights out, torch, and you can see and the actual real life effect there on the right hand side. And you can see at the bottom of the tank there, you would see the smokiness starting to appear. Okay, and this was when I was given the talk and the to Mac there a few years ago, and you can see the light, everything is in place there, and we were just waiting at that stage for the action to take place. Now, what is actually happening is when you need a very, very low temperature, like I think the dry ice goes to -78 Celsius, I think. And what happens is that the alcohol is in liquid form. It tends to fall from the felt. When it hits the bottom, it goes into a gaseous state. The temperature, the cold temperature keeps it nice and into a gaseous, almost smoky state. And any particles passing through it then interact with the particles of the alcohol, and you get your impressions. Now, what do you see? What can you see? What can you? So if you see short, fat tracks, these are not cosmic rays. You see short, fat tracks, you're seeing an atmospheric radon atom. Now, we've all heard of radon, you know, keep your houses clear of radon, keep the windows open, aerate the houses, don't build on granite. You know, build up of radon can be bad, very bad, but in normal circumstances, atmospheric radon is of no harm for it. Radon is naturally occurring radioactive element, but it exists in such low concentrations in the air that it is less radioactive than peanut butter. Yeah, unless it's locked in your house. Alpha particles spat out of radon atoms are bulky and low energy, so they leave short, fat tracks. The diagram on the left shows what they propose you see. Here is one that I captured, and it's from a short. I made several videos on that of the process, and this is a enhanced image of one of the radon tracks. You see it here. So they started to appear very, very early on in the process. Now, like I say, when you really need to see this in action, because they're quite spooky. They just sort of fade in and fade out, and they're traveling, and it's quite an event when you notice them at first. Sometimes they can be hard to see. The next one is a long straight track. This is a muon. Muons are the heavier cousins of the electron and are produced when a cosmic ray bumps into an atmospheric molecule. And because they're so massive, muons bludgeon their way through the air and leave clean, straight tracks. So, now, I know you're going to say this is not a straight track, but I think actually that's an artifact of I was using a bulb, basically, you know, so the light was a bit distracted. But if you see it when you're watching it with the naked eye, see it as a straight track shooting through the murk. Again, I had to enhance this one because if you saw it in the original as a captured image, you barely notice it, but in the video you would see it. I'm going to try and show you some of the video earlier on, but the last time I tried to show a video, it didn't work, so I don't know whether it'll work tonight or not, but we'll see. Zigzags and curlicues. If your track looks like the path of a lost tourist in a foreign city, you're looking at an electron or positron. Electrons are created when a cosmic ray crashes into atmospheric molecules. They're light particles and bounce about when they hit molecules, leaving zigzags and curlicues. So what do we mean? Again, the artist's impression, and then one of the real things there on the right-hand side. There we go. There's also, you might, I don't know whether you can notice or not, but there's also another particle streaking through here, and there's a bit here. There's also something else going on here, but at the moment, what we're talking about here is just the curlicues or the electrons. Fork tracks. These are the ones you really want to get. You just saw a particle decay. Many particles are unstable and will decay into more stable particles. So these are the tracks of a particle decaying. Now, this one is a little bit harder to see. Okay, we have a track going here. Oh, sorry, I need to go back here. Oh, sorry, we're just where? This is the fork track. You can see it here. Going off down this way and splits and goes down here. There's also on this one, there is another here and one going this way. Again, very hard to see, but they are there. This one is a little bit more defined. But like all of these things you'll see very rapidly coming in, and it's just like I said, to me it was wow. This, you know, I can see particles, fundamental particles. You see physics in action, and this coming back to the spooky nature of it, or sitting like a seance. It's like a, you know, Madame Zelda's crystal ball. We're all staring into it, but it's something to see. Like I said, that's basically it. What I'm going to do now is I'm going to attempt to see. Will you be able to see the video? Now, tell me very quickly if this doesn't show up. And can you see that in action?
Yes.
Yep.
Yeah, you see like the waves, like waves on a sea. That's the no. There's particles starting to appear there. You see?
Yes. See one.
Yeah. There, it's more. There's yeah.
Yeah.
Now, to see that in a darkened room is, yeah, I suppose it's eerie. It's eerie enough. Yeah, it's yeah, that's that's basically it. Like, I mean, there isn't a whole lot in that this to give a full-on lecture unless you start going into want to talk about subatomic particles and everything. But what attracted me to it was that you could very easily set up a from your own in your own kitchen a cloud chamber and watch this in action. I remember the first night we had it, I got Bob to call in, and we set it up on the kitchen table and we had a look, and like we were gobsmacked, you know, because you know when you do these things, you say, this won't work, you know. And we're waiting for 10, 15 minutes and nothing was happening and everything. And then suddenly they started to appear, and God, it was brilliant. And like similarly then when I gave the talk down in St. Catherine's to the club, it was great. You worry a bit at the start, it's not going to happen. Then once they start happening, they start appearing, you know, and it's pretty cool. Now, any questions?
Oh, I was at that lecture.
You were, yeah.
It was very good. You just, you know, like, I mean, you were talking about, and you didn't oversell it probably when you were doing it, like, and just that happened. But as you said, it just the magic happened, you know. That's
yes, yeah. It's been there and seen it in action, isn't it? You know, it's you know, like you know, that's
then when you don't know much about anything, you just kind of think, geez, where did it come from? Where they're going?
Yeah. Yeah, well, it makes you think that all these things are going on around us all the time. Now, what you're able to see in a homemade cloud chamber are the heavier particles, you know. So there's probably an infinite number of smaller particles, you know, that you
neutrinos.
Yeah, like, you know, and look what you have.
Zipping right through you, never interacted with a single atom.
Yeah, yeah.
We just need a large block of ice to see neutrinos.
Do you really?
Oh yeah. about what 500 meters below the Arctic or somewhere. Yeah. But actually, if you think about it, it's the same principle. You know, you have something. What do they use for neutrinos? It's a clear, pure. Is it alcohol again or something? I don't know what.
Hexafluoride or something. Yeah, it's basically.
Yeah, it's
the one in Japan, like the Kamiokande one, I think is that, and they just have the photomultiplier tubes around the edge.
Yeah.
And they wait for, you know, every so often one of the.
Do you think we got the funds to make one here?
A small one.
We can put it in the Alloy Caves or something.
Yeah. So, like, as the radiation, it's like a radiation detector, the cloud chamber.
It is essentially, yeah.
Yeah, and it kind of reminds me of, for example, one of our early star parties, the Astrofests, where Neil Bone had the jam jar magnetometer, and I think, Sean, you had one at one stage that was able to use a sensor to generate a noise when the magnet came out of sync.
No, that was my magnetometer that Neil Bone had. It wasn't his; it was mine.
Okay, I was kind of wondering then, could it?
Well, actually, it was Bob's that cloud chamber. Bob made that.
Yeah, could an audio sensor of some kind be used as in the audio in the chamber, to give off like an audio every time, like a little ping or, you know, a beep or something like that?
I'm sure it is, but you see, the problem with doing a cloud chamber like this, you're using dry ice. Now, that's going to be gone in a day. You know, that block of ice, it literally vanished in a day. It just vanishes. It doesn't, doesn't get soggy, wet, or anything. It just evaporates and it's gone.
That was going to be my next question: was how long does it last? Yeah.
Yeah, that's basically little more than 24 hours.
What's the temperature of the dry ice, Sean?
I think it's minus 78. I just show you. It's on. The box is there. Wait, I might, if I can. What I do is I just get out of this here now and see if I have. Yeah, it's written on the box.
Can you get the dry ice sent to you by courier?
Oh, you can, yeah, you can order it online. You know, no, like I say, I don't know how much to check, but yeah, it came with the most important thing is gloves. You need heavy duty gloves, and it came with heavy. No, yeah, minus. I just
78, I think, yeah.
minus 78. Yeah,
Yeah.
that's the temperature. But it's my laptop's gone like Jason's now. It's refusing to. Oh yeah, minus 78. Yeah, that's. But yeah, oh yeah, they're actually they're very nice. I put up a piece on their page afterwards, thanking them for it and everything, and it came back to me, and they were very appreciative. But yeah, like unfortunately, my neighbour, he was one of the directors. It was a family business, but one of them bought the rest of them out, and he's no longer involved with it. So the next time, if I ever want to do this again, I'm going to have to pay for it.
Funny enough, Sean, there's a work colleague of mine is now the new manager of Polar Ice, so I still might be able to swing some free ones for you.
There you are, connections all around. yeah.
Ronan Berry.
All right.
Excellent.
Excellent. Yeah.
So yeah, he's high up there with Alison Ritchie in the business.
You're right. Excellent. But yeah, no, there is you can get an electronic means to cool, to cool it down. You can get an electronic cooler to bring it down to that level,
I did wonder whether you could get a Peltier cooler and do it that way.
Yeah, then you could start thinking about other things like Sean, what you were saying about setting up detectors and that, sensors and that. Yeah. But you need an unending supply of dry ice to make it anywhere to maintain the other. Yeah. And unfortunately, like a normal fridge or anything that just won't get you those sort of temperatures. So that's. But I just thought at the time it was an interesting thing, and like there isn't enough in it as you can see there for a full-blown hour-long lecture, but there's enough of an interest. If you go on the web, you'll see that it's all geared for schools.
Yeah, I was thinking that'd be perfect if we get out into doing outreach in schools, because you can make it very, very quickly. And then when you flip it over and you set it up and then lights out the classroom, it'd be a great tool for us to use in schools.
It would be.
And you guys, Michael, up in Dublin, next time you're doing something in Dunsink.
Yes. Because I'd wonder actually, if you could put set a magnetic field up across it.
I was going to ask that as well, and I thought it'd be really now you're talking pay grade.
And influence the track of the the tracks and see what can you.
That's how they measure the charge on particles, and because I remember vaguely, I've seen pictures of the ones, and you see, as I said, you have the spirals.
Yeah.
And it's just it's the and you can tell whichever way the spiral going, whether it's an electron or a positron or
Yes, yeah, yeah.
mass.
Yeah, because if you do, when reviewing the movies, now, like, I mean, I've loads of different movie clips, and you can actually see that they come in, a lot of them come in the same way, but some behave slightly different, as you say, like, you know, some would spiral to the right. Most of them would spiral to the right, but then occasionally you get one that will spiral to the left, you know. So yes, you know, it's good. That's good to observe like that.
What kind of a magnetic field, Michael, do you think you'd need? What kind of power? I mean, you're talking about putting a lot of speakers lined up around it, or something from a scrapyard type.
Well, could you build an electromagnet? I'd have to go look it up.
Yeah.
I know you can buy, like, you can buy quite powerful static magnets.
Hmm.
I think the neodymium, or however you pronounce it.
Oh yeah.
But I think I'd have to dig out my my physics book and figure out.
Yeah. I have a sneaking suspicion you might need that heavy of a magnetic field, you know, to influence it, you know.
Brendan says there in the chat, by the way, €46 for a 10K ice block.
Okay.
Sounds cheap.
Yeah. What is?
Thanks, Brendan.